Hello viewers, let's check on this one. Why do the total surface area under a velocity time graph is equivalent to the distance traveled? Interested in what is coming over? Don't forget to subscribe, like and share to your friends who are in need of this knowledge. Let's go. Hope you are able to see this figure very well. This is a velocity time graph. You can see here this is a velocity time graph, and the way it is plotted, it is describing two shapes. Here we have a square and here we have a triangle. But we know that the total surface area under the time graph, the velocity time graph, will lead us into the total distance traveled. But we don't know why is it that so. Now let us see the sum of these areas. Now the total area will be the one of a square or a rectangle plus the one of a triangle. That is the total area. But what do we know about the total area? The area of a rectangle or a square according to this figure is length times width, which is u times t. Then plus area of a triangle is, according to our figure, it is a half times base, which is t, then times height, which is v minus u. It will be a half times base, then times height, which is v minus u. But we know from the first equation of motion that v is equal to u plus a t. From this one, we're able to get v minus u is equal to a t, and hence acceleration is equal to v minus u over t. Now what we need to do is to bring in the acceleration here. Let's see. Now we are seeing that from the upper equation here, if we just multiply t and then we divide t, according to mathematics we have done almost nothing, because this t can immediately cancel with that one. Yes, we already know that v minus u over t is just the rate of change of velocity, which is the acceleration. Then we put it here, and then t times t is just t squared. Do you understand what this equation is? This equation, u plus ut plus a half at squared, is the same as the second equation of motion, which always gives us the distance traveled given the initial velocity and time, then plus a half times acceleration times the square of the period or the time taken.